In this brief video, we're going to present our application for Dataspace Immersive Insights. And in particular here, we can see how we use the screens in immersion mode in order to analyze some toy dataset that we introduced just for this specific use case. So we can see here that we have two screens combined together to see the raw data of which we can see the data samples, that they are countries, so Australia, Austria, Belgium, and then the features, educational attainment, student skills, years in education, and so on. And in particular, these are indices of education or economy for these countries, given by the OECD. So we can see that we have other views. We can select different data sets. We have feature distribution view, where we can see that some distributions are actually a bit skewed. We can see that there are some outliers here and there and some statistics. We have a data filtering and a feature engineering view. We have a projection view, where in this case we see a PCA on the first two components to visualize the 34 data points. And then we have some feature correlation and feature selection views. Here, for instance, we can see how educational attainment is positively correlated with student skills, and how, for instance, educational attainment is negatively correlated with working long hours. Whereas we have a 2D view there, here we have a 3D view of the dimensionally reduced space. And in particular here, I can hover with my gaze on the countries and see their name, but I can also say show names, and here I can see all of them. Particularly, I can see that there is Japan. We can see Japan and Korea on the top left. We can see a central cluster that is pretty much European countries, and on the right we can see some outliers. For instance, Portugal, Chile, Turkey, and Mexico. Few things we can do here is that I can change the dimensionality reduction method, apply isomap, and here whenever we have an update, the update is reflected on all the other views. So we can see that the points moved here, but they also moved in the 2D projection there. Apply agglomerative clustering with 4 clusters. So in this case, we can see how a clustering view got populated, and from that matrix we can actually describe the clusters and see how Japan and Korea have, in our case, very high student skills, but also very high working long hours and low self-reported health, whereas our outliers from before, Mexico, Chile, and Turkey, actually have very low features in everything except for working long hours, that is very high. Another thing we can do, apply PCA, is to leverage the depth clues that we have with the stereoscopic vision to see axes in 3D that indicate how the features are distributed. This is called a 3D biplot. And we can see how this axis represents self-reported health. This one is educational attainment. And here we have student skills and working long hours. So for instance, we can see that student skills is positive green in that direction and negative in this direction, meaning that all the points towards this side of the projection are going to be with high student skills. If we check the self-reported health, going negatively in this direction, we can see, for instance, that Japan and Korea are in this subspace, this particular subspace where we have high student skills and very low self-reported health. And this helps us understand how the dimensionality reduction works. So another interesting thing that we can do is to try to subcluster one of our clusters or a selection of the data in order to discover features that would not otherwise be easily to discover. So for instance, select all countries with student skills greater than 500. In this case, we can see how some of the data points have become black and how the other ones have remained colored and be selected. And in particular, we notice that we pretty much have just all the data points in this subspace where we have student skills, education attainment very high. And we can actually confirm if we check the distribution where the mean, for instance, is 497. So let's suppose that now we want to try to cluster, but only on these data points. So at this point I can say isolate. And here, if you notice, we have a new axis, only the subset of interest of our point, and the clustering and the dimensionality reduction are automatically recomputed, and we can actually see that Australia and New Zealand are actually similar, Canada and Switzerland go together, and then we have our previous cluster of before, that is Japan and Korea. And by looking at the heat map here, we can actually find new descriptions for these structures within the same cluster. At this point I can even say restore, and in this case we have the data points of before, where the selection is kept in the data table, and here I can simply say clear selection. And here I simply go back to our original situation.